Okay, so I'll just put this into presentation mode, then we can start. So for those who are here for the first time, my name is Dr. James Katende from the Department of Mathematics at the University of Nairobi, and this is the CAPEC Kenya Mathematical Olympiad Training webinar, which runs every 2 weeks. And we discuss questions and related topics during the meeting. So we have some questions we'll be discussing today. And please feel free to interrupt me if you have any questions. Just if you have any questions midway, you just put on your mic and ask. We want to make this as interactive as possible. So we have a total of 4 questions, and this is the first one. What we usually do is we give a few minutes for the participants to try and solve the problems, or at least get some ideas on how to solve the problems before we proceed. So here's the first one. I will read it, then I will give a few minutes to the participants in case there's anyone who has some ideas on how to proceed. So the question says, when 2007 bars of soap are packed into n boxes, where n is a positive integer, there's a remainder of 5. How many possible values of n are there? So that's the question. Feel free to have a go at it and share some of the ideas you have. Any ideas?
My answer was 120. Is that on the right track?
It's a little too generous.
For me, I got 14.
Yes, 14 is correct. Do you want to share your solution, or we go to our solution?
I don't mind sharing my solution.
Mm-hmm.
So from the question,
yes,
you have 2007.
Correct.
So there's a remainder of 5 somewhere.
Yes.
So you subtract 5 from 2007, you get 2002.
Mm-hmm.
Then from there you do a bit of prime factorization. So this one was a bit easy since, okay, I got, initially I factored it out, I got 1001 times 2. Mm-hmm. Then of course 1001 is divisible by 11, so it was quite smooth there. Mm-hmm. So you'll get, there are 4 prime factors, each raised to the first power.
Yes.
So if you try to find the number of factors of 2002, so yes, it will be Okay, using the formula, you'll get 16. There are 16 factors.
Yes.
But then we have to eliminate the cases that cannot give a remainder of 5, which is 1 and 2. So
Correct.
6.
Okay, so there are 16 factors and you drop 2 to meet the conditions. You're left with 14. That's correct. So it's the same thing we did. The first thing was subtract 5 from 2007 to get 2002. And this means that now the number you're looking for must be a factor of 2002. And it also must be greater than 5 for you to have a remainder of 5. So those are the 2 conditions we need to impose to be able to find the possible values of n. Again, you do the prime factorization. And once you have the prime factorization, it's quite easy to work out the number of factors or divisors of 2002. So if you have the prime factorization of a number and you want the number of divisors, including 1 and the number itself, then what you do is you add 1 to each power of the primes and then multiply the resulting powers. So in this case, each power is 1. When you add 1 to each power, you'll get 2. And then you multiply each of those new powers and you get the total number of divisors. So there's a general technique for this. This gives you 16 in total. So if you impose the condition that n should be greater than 5, then you have to knock out the factors 1 and 2. And therefore you have 2 less factors to consider. And that means the number of possibilities is exactly 14. Only n possible values, 14 possible values for n. Are there any questions on that? Jeremy, have you seen the...
Yeah, I think the problem is instead of adding 1 to all of them, I added 1 to the first one, 2 to the second one, 3 to the third one. I think that's where my mistake was.
Okay. Good. So now let's move on to the second problem. So here is the second problem. It says a small square was cut off the border of a large square sheet of paper as shown in the figure below. So as a result, the perimeter of the square sheet of paper increased by 10%. So the question is, by what percentage did the area of the sheet decrease? Again, we can give you a few minutes to have a go at this and share some of the ideas you develop.
Is it 4%?
Yes, I think it should be 4%. I don't
Yeah,
want to give out the answer, but let someone else try. Anybody else with a different answer? How did you get the 4%?
Okay, so first I found a ratio between A and B by using the statement that the perimeter of the square sheet increased by 10%, because here the only added perimeter is 2B, because of the, 2 sides of that square are added. So 2B equals to 4A over 10, because 4 is the perimeter of the larger one. So B equals to 1 over 5A. If you kind of simplify that, and then to get the ratio between B squared and A squared, you just square 1 over 5A, which is 1 over 25. So, which is 4%.
Okay, that's correct. So basically it's the same thing we did. So today it looks like the questions are too easy. So we use the labels that we have. We have the length of a larger square, the side is of length A, and the smaller square, the side is of length B. And of course, the perimeter increases by 2B. If you go back to the diagram, you can see these two pieces are what increase the perimeter. Just this part and that part. That's the increment in the perimeter. So that would be B plus B, which gives you 2B. and that's supposed to be 10% of the total perimeter, which is 4A. So we can write it as 2B is 0.1 times 4A, which gives you B is the same as 0.2A. And if you square both sides, you get the area by which the area of the amount by which the area of a larger sheet is decreased, which is B squared. That B squared is the area that you cut out. So that's the amount by which it's decreased. And it turns out to be 0.04 of the total area of a larger sheet. And that is exactly 4%. Any questions on that? It all makes sense, I hope. Okay, so we will move to the next question. This one may need a bit more work, but I will read it. A math teacher writes 10 consecutive integers on the board. They don't have to be all positive. And she promises to give an A to each student who can choose a number which has not been chosen yet by another student, such that the sum of the remaining numbers is a perfect square. So what is the largest? That's a spelling, it's a typo. It's supposed to be, what is the largest number of students who can get an A? And then you need to clearly explain why more A's are not possible. So any progress? This one is taking a bit of time. Anyone who has some ideas? So you have to read the question carefully. It means there are 10 consecutive integers on the board. And at any one point, you need to pick one so that the sum of the remaining numbers is a perfect square. So how many in how many ways? What is the largest possible number of ways of numbers you can pick in a sequence of 10 consecutive integers so that the sum of the remaining numbers is a perfect square? Okay.
Can we have maybe 2 more minutes?
Okay, exactly 2 more minutes. Anyone with some ideas? Or anyone who has solved it?
Okay, so the only idea I've had so far is that the numbers can be divided into 3 classes, 3x, 3x plus 1, and 3x plus 2. And all perfect squares can only land in either the 3x or the 3x plus 1 group. So I'm still working on that clue or that idea.
Okay, I've not explored that idea, so I'm not sure how far you can go with it, but there might be a pathway along those ideas. What I can do, let's just look at our solution and we see how we can proceed. So we need 10 consecutive integers. So that is these numbers, a plus 1, a plus 2, up to a plus 9. That gives us a total of 10 consecutive integers. So suppose these are the numbers that are on the board, and we denote their sum, the sum of these 10 numbers, by capital S. So capital S is the sum. So we now consider all the possible sums of the remaining 9 terms after one number is deleted. So if a student picks the first number A, the sum of the remaining terms will be S minus A. If a student picks the number A plus 1, the sum of the remaining terms will be S minus A minus 1. So this goes on like that until the last term, where the sum of the remaining 9 terms, if A plus 9 is picked, will be S minus A minus 9. So if you look at this short sequence, you will notice also that these are 10 consecutive numbers as well, because this next number is more than A, S minus A by only 1. The next is more than the previous one by 1, and so on. So they're actually 10 consecutive numbers representing the sums. So this just repeats what I've said. This are 10 consecutive integers. So we need, the question now changes to what is the largest number of perfect squares that can be found in a list of 10 consecutive integers. So that's the equivalent question now that we can solve. And now we apply it to this new sequence, because these sums are supposed to be perfect squares. And here we have a list of 10 consecutive integers. So what's the largest number of perfect squares that can occur in that list?
Is it 3?
Not yet.
Okay.
You are off by 1, but you will see why. So you can make a few guesses here and there to get a pattern. So if you check from 0 to 9, we have exactly 4 perfect squares. That is 0, 1, 4, and 9 itself. If you go to from 1 to 10, we have 3 perfect squares. That is 1, 4, and 9. If we check from 2 to 11, or we check 3 to 12, or 4 to 13, we only get 2 perfect squares in each of the sequences, the 3 sequences now. So what do we do with this? We can make some guesses. It appears that 4 is the largest number of perfect squares you can get. When you go higher, from 1 to 10, you get fewer. You get 3 perfect squares. And from 2 to 11, 3 to 12, and 4 to 13, the number is not increasing. We only have 2 perfect squares. So we can make some claim and try to prove it based on these experiments. So far, it looks like the largest number you can get is 4. So let's see if we can get anything bigger than 4. That is if you can figure that out, then our work is done. So we make a claim that there are at most 2 perfect squares among 10 consecutive integers whenever A is greater than 4, right?
Isn't it at most 4?
We are changing. There are some conditions we have added here.
Okay,
when A is greater than 4.
I see.
That's going to clear that in a short while. So suppose we have 3 perfect squares in the list. So the reason, because when we start from 4, going up, we have seen we only get 2 perfect squares. Anything below 4, we have seen we get either 4, 3, or 2. So we want to figure out what happens if you consider all numbers A greater than 4. So we've seen it's possible to get 2. The question is it possible to get 3? So we make that assumption that we have 3 of them in the list. And we call them x squared. And the next perfect square would be x plus 1 squared. And the next one would be x plus 2 squared. So the trick is to find out if the distance between this first perfect square and the last one is more than 10. If it's more than 10, then it's not possible to get 3 perfect squares. So if you have x plus 2 squared minus x squared gives you the difference between the largest and the smallest perfect squares in the list, which is 4x plus 4. And you will notice that whenever x is bigger than 2, in which case there's this smallest perfect square is 4, whenever x is bigger than 2, then this difference for x plus 4 will be greater than 10. So that means for us to get 3 perfect squares in that list, we will need more than 10 consecutive integers to obtain them. And that means we can't get more than 2 whenever a is big, whenever we consider 10 consecutive integers, with the first one being bigger than 4. So the largest that we had gotten earlier was 4. The largest number of perfect squares was 4, and therefore the highest number of A's that the teacher can give is 4. I hope that makes sense.
Yeah, it makes sense.
Yeah. Anybody with questions on this?
So I also, like, when I read the question initially, I interpreted it like I interpreted the statement that what's the maximum number of A's the teacher can give to mean that, let's say the first student removes and then the rest form a perfect square, so he gets an A, and then another one removes from what remains, then another one removes from what remains. But it seems that the question was to be interpreted differently.
Or maybe we should have made that clearer in the statement of the question.
Okay, thanks.
It's possible there was some ambiguity in the statement of the question. Let's see. So maybe I should have added such that the sum of the remaining 9 numbers is a perfect square.
Makes sense.
Yeah. So there's one last question here, which says, let x and y be 2 positive integers which satisfy this inequality. What is the minimum value of x? Any ideas?
Okay. So the only one I have so far, I don't think it's that important, is that for x to be minimum, then the fraction has to be maximum. So it has to be as close as possible to 200 over 251. And in my thinking, that should be 200 over 250. No, wait, that will be larger than it. So yeah, I think the denominator should be 250, and then the numerator should be something that can simplify with it.
But it's possible to find smaller numbers at work.
Yeah, that's why like the numerator can like simplify with it to form a smaller number. Like they have common factors.
Maybe we should just look at the solution.
Oh, I got the answer, maybe.
Yes.
Is it?
Did was that Claren?
Yes, yes.
You said?
Okay, my answer is 3.
Yes, 3 is correct. How did you obtain the 3?
I think I was just lucky to observe that 100 over 151 is slightly less than 2/3.
Okay, that's it's not a very good method.
Yeah.
Correct, but through guesswork. Let's
Yeah,
see
so
how.
maybe with this idea we can start like from by putting 1 as the denominator and then like gradually going up, because nothing over 1 will be in that range, nothing over 2 will be in that range. And then like with 3, if we play around a bit, it'll work.
Okay, that testing of values is a good idea, and we use that idea also in the solution. Maybe we should go ahead and look at it. So it's possible to what we did here was to rewrite the inequality. Let's go back to if you get the reciprocal, since all these are positive numbers, if you get the reciprocals, the inequalities will be reversed, right? So all through get reciprocals, so the inequality is reversed. So that instead of less than now, we will have greater. Oh, I may have.
Isn't it x over y?
Yes, it should be x over y. That's why I'm pausing. So this should be x over y. It is correct in the next statement. In the first one, there's a typo. It should be x over y. So just note that correction. This should be x over y, and we'll carry that correction forward. So we try to put everything over the same denominator so that we have 302 over 200 is greater than x over y and greater than 251 over 200. Then we multiply throughout by y. And since y is positive, the inequality is preserved, but we're left with only x in the middle. So now we test for different values of y and see what is the smallest possible value of x that we can get. If you try with y is equal to 1, then there will be no integer between these two numbers, right? If you try with y is equal to 1, but if we try with y is equal to 2, we get this will be just a little more than 3, I think, and this will be a little more than 2, right? So in between, the only integer that we will get is 3. And that's the smallest possible value you can get. Now you can get larger values by increasing y, but the smallest you can get now is when y is equal to 2. And when y is 2, the only integer that lies in that interval will be 3. And that means the smallest value of x is 3. So that was looks rather deceivingly short. That's the solution. It makes sense?
Yeah.
Okay, any comments? The floor is open now. Anybody can make some comments? Maybe I can stop sharing the slides.
Asa, could you please share with us the link to the YouTube channel?
Okay. Okay, as we wait for questions, I can look up the link and share it. I'll just go to the net and look for it. But in the meantime, if you have any comments, any ideas, please feel free to share. Or if you have thought of an alternative solution to what we already have, you can also share that. It's all good. So I'm just trying to get the link where we have some of the older Okay, I think I've found it. I need to find the playlist. Yeah, here it is. Okay. So I'm going to paste it in the chat. So you can get the link from the chat, the link to the playlist. So on that playlist, we also have some previous lectures where we covered some topics. I think we covered inequalities. That was covered by, well, I think the inequalities have not been uploaded, but we have trigonometry. And I think there was one class where we covered quadratic equations in detail. So we only spent the whole class on quadratic equations. So it may be a good one to watch. I can also arrange to share the slides. I will need to make some of the corrections on the slides before I share. So are you able to access the link?
Yeah, it works. Thanks.
Okay. So ladies and gentlemen, thank you very much for coming to this meeting. It would be no meeting. If you want there, I would just be talking to myself, but at least now I have an audience. My hope is that everyone got something of value and is excited about what we are doing, and hopefully learn something new as well. So any feedback on that?
Just one question here.
Yes.
James, my name is Hawkins. I am with KQ. I was invited to this forum by my colleague here, Christine.
Yes, welcome.
I remember a few, thank you.
Mm-hmm.
I remember a few weeks ago, we discussed how we could support this forum.
Yes.
And I decided to log in to just to listen to it and maybe kind of get ideas.
Yes.
I don't know. In what way as KQ could we support you? I think we talked about the tickets one. That's something that's already in works.
Yes.
Of course, that's for next year now that we'll not be having a travel for this year.
Yes.
But going forward, are there any ideas that maybe you have, or your team here has, that we can support? I think there was an aspect we talked about supporting the training. I don't know what you had as an idea or how we can come through.
We are working on our document. I think by tomorrow I will have something on paper.
Okay.
I'll have a meeting with my colleagues. Then I can share it, I think, by end of tomorrow.
Okay.
The biggest challenge now we have with it, a good way of doing this is the physical training, but the biggest challenge we now have is gathering. So we are trying to work away around that and see how we can overcome that challenge, so that even if we do it online, we're still able to reach, do it effectively. But if anyone in the group has ideas now, I think you can still share. There's no that.
Let me know. I'll wait for the document.
Yes.
I know you're in contact with Christine. Once it shows up in our mailboxes, we'll review it and maybe set up a call where we can discuss.
Okay. Any feedback on the class itself?
No, the class was good. At least I saw some participation from the group.
Yes.
And there were interesting problems to solve as well. So yeah, I think this is something we'll be very much encouraged to participate in.
Okay, thank you very much. That's for the kind words. That's really encouraging.
Thank you.
And
thank you.
Thank you to Christine as well. I think I saw Christine in the meeting for showing up. And we appreciate the support. So we will expedite the write-up so that tomorrow we send it to you.
Okay, so thank you.
Yeah, hello, Mr. James.
Yes.
For me also is the first time I'm Wafula.
Yes.
From Clay International Secondary School.
Yes.
It's also my first time to participate in your meeting. And it has been a good meeting. We are looking forward for more and more information from you guys. Yeah, I was connected to you by Ben Mutua, our director.
Oh, okay. That's very nice. I've been in communication with Ben during the competitions.
Yeah. I'm a teacher in his school.
Yes.
Yeah, I'm happy to be actually it has been a good meeting.
Oh, okay. Thank you very much. We do this every 2 weeks. So we keep sending out the information when we are about to have it. Then if you can use the same link though. We use exactly the same link. So once you have it, you can use the same link to join us again in 2 weeks' time.
Right away from this meeting.
Pardon?
Right away from this meeting, count 2 weeks.
Yes.
Okay.
Okay, then you can watch some of the previous videos on the YouTube link that I shared in the chat. So
I've gotten the link.
Okay, I think we can stop there for today. Wish everyone a good evening, and let's keep meeting. We meet again in 2 weeks, and thank you very much for showing up. Have a good night.
Good evening. Thanks.
Yeah, good night too. Bye.
Yes, thank you.
Bye.